So this question, a vehicle of mass m starts moving along a horizontal circle of radius r. Its speed varies with the distance s covered by the vehicle. C is equal to k into root s. So this is the um, c velocity is equal to k into root s. Velocity as a function of displacement has been given. Calculate the tangential and the normal force on the vehicle. Tangential normal force. Normal force is nothing but due to acceleration which is acting towards the center, which is v square by r. And so the force is mv square by r if this is acceleration. So m into v square is k square s by r, r being the radius, mk square. So that will be the normal force acting on it. And what about tangential force? A tangential force is nothing but F is equal to m into a, and when you know the velocity is k into root s, you can find acceleration, which is dv by dt, which is k into root s is 1 by 2 root s into ds by dt. ds by dt is nothing but velocity, and substituting k by 2 root s into ds by dt, which is velocity k into root s get cancelled, k square by 2, and therefore the force acting the tangential force will be m into k square by 2. So this you calculate the tangential, this is the normal force, this is the tangential force. Next is the distance s in terms of time. Okay, they have already given that c is equal to k into root s. You have to find the distance s in terms of time, which means this can be written as ds by dt. Velocity is k into root s, taking the dt to the other side and integrating both sides, you'll get distance 1s, 1 ds, which is s, k is a constant. Root s is s to the power 3 by 2 by 3 by 2. But this is in terms of dt. So the something is not okay with what I have written. Okay, you write you have to do it as variable separable, because this is ds by dt is equal to k into root s. How can you take dt that side and integrate like this? Because there's a t here and this is s, so you have to bring variable separable. In physics, in mathematics, you all know it's 1 by root s into ds is equal to k into dt. You have to do it like this. So when you do 1 by 2 root x, it's 2 root s is equal to k into t. Okay, the distance, therefore squaring both sides, 4s is equal to k square t square and s is equal to k square t square by 4, and that will be the distance. B's answer in terms of t. Let's go to C. The work done by the resultant force in the first t seconds. Work done by the resultant force the first t seconds after the beginning of motion. The work done is nothing but a change in kinetic energy. And the change in kinetic energy, so the initial energy minus the final energy. So initial, if it's initially at rest, or final minus initial, which is half mv square. What is velocity? You know the velocity is nothing but this is the tangential velocity, which is k square into change in kinetic energy. So in time t, how much would be the velocity? So let's differentiate this, because it's s. When you differentiate, you get velocity. K square is a constant, 2t into dt by dt, and a 4. These two get cancelled. This is your velocity. Let's substitute this velocity in here, because in a time t, so half into m into k to the power 4 into t square by 4. So can I say m k to the power 4 t square by 8? And this will be the change in, it's work done or change in kinetic energy. Let me see the answer. Yes, so that's the answer. This is how you do the sum. Such a beautiful sum. You have to find what is s and then differentiate, get the velocity at that instant. You can't randomly take what is given in this and substitute, because there's no time here. And so then make sure that in time t you have to do it only that way. The next question. A person walks in this path. Okay, there's a 4 meter and there's a semicircular path which has got radius as 1 meter. There's again a 4 meter. person walks along the path shown in the figure. The path from B to C is a semicircle centered at O. If the magnitude of the displacement of the person is 2 meter, the displacement is 2 meter, then obviously radius is 1 meter. So with that only you can write what is 1 meter. Okay, anyway, the distance traveled by him. The distance traveled by him will be 2 pi r. Is going to walk from B to C. The magnitude of displacement of the person is given to be 2, which only shows the radius is 1. The distance traveled by him totally, okay, he's traveling from A to B, it's 4, another here also it's 4 plus 4 8, plus a pi r, because this is a semicircular path, and so 8 plus pi, r is just 1, so 8 plus pi units is the distance, or meters is the distance through which it's traveling, he's traveling. And 8 plus 22 by 7, it's 8 plus 1.414, so it's 9 point, and you don't even have such an option. It's 8 plus 8 and a pi r. Distance traveled by him, 8 plus pi r. Yeah, it's 8 plus pi is the answer, but you don't have an option like that. You seem to be having a different. This is 3.414. Sorry. So sorry guys. So 11.4. So we got it. Okay, so let's go to. You have some approximate answer. You can mark that, and let's go to next question. The displacement x in meters of particle of mass m kg moving in one dimension under the action of force is related to time. Okay, let me see this. Okay, they have given the displacement as a function of time t minus 3 the whole square, with which you can find velocity. The velocity is differentiation of this 2 into t minus 3 whole to the power 1. You can find acceleration, which is 2 meter per second square. But what is the question? They have given this, you found the velocity, but acceleration, we are getting it as constant acceleration. Okay, and they are asking work done by the force in first 6 seconds. So it's dependent on time. The first 3 seconds, you can't just say the acceleration is a constant. So you have to find the velocity at first t seconds when t is equal to 0. The velocity at t is equal to 0 will be minus 6, and at time t is equal to 6, at the velocity at time t is equal to 6 will be plus 6. Therefore this is your initial velocity and this is your final velocity. So then therefore there is a change in the velocity in terms of directions. Yes, there is a change in the velocity, but if you see there's no change in the kinetic energy, because it's half m u square is also the same value, half m v square is also the same value, so the kinetic energy remains a constant throughout the journey, and so the work done will therefore be 0. Okay, so there's no point in calculating acceleration in this sum, because you need to know what is the initial velocity, whenever they ask you work done, it has to be based on energy calculation. So I hope you understood that. So the next question is ABCD is a parallelogram, where this is ABCD is a parallelogram, vector A, vector B, vector C, position vectors. Oh, they are all position vectors. A, B and C, D has been given. Okay, with respect to the origin, saying OA, so there is some origin somewhere. Okay, this about OA, OB, OC and OD. And you're joining these and you're getting a parallelogram. Oh, A plus B is equal to C minus D. Okay, some A plus C plus D. A, B, C. No, the thing is, they're all position vector from the origin. Okay, so when it's all from the origin, it's a point, you have to get a parallelogram based on this. So then you could have position vectors. So this could be the parallelogram. I'm doing it like a cuboid though. So this seems like a rectangle, but still imagine it to be a parallelogram. So then this is a parallelepiped, it's not a parallelogram. So if you want a parallelogram, it's only one of this. Let's take only one of this. Okay, let's just take this one alone. Just this one alone. And you know that this can be your A, this can be your this can be your B, this can be your C. The position vectors, you need one more, which is this could be your D, which is the distance from the origin. This distance from the origin. Okay, so this distance OA, OB, OC and OD have been given. Okay, so then so this has been given. Is it recording? Yes, it's recording. So they have not done all this. Okay, so don't have to confuse with all this. So just do a parallelogram ABCD. You know the opposite sides. This is a parallelogram. This is AB. This is BC, CD, AD. You know that the opposite sides. This vector will be like this. This vector will be. So they'll cancel out. So you can say AB plus CD. AB and a vector CD will be equal and opposite, so it will be 0. Similarly, you will have a BC plus an AD which will be opposite, and so then therefore the sum of these two will be 0. So AB plus CD is equal to 0. So that's the option, is it? That's the only thing that is there in the option. Okay, what is AB therefore? The AB itself is B minus A. AB vector is B minus A plus CD vector is D minus C is equal to 0. So can we say B plus D is equal to A plus C? B plus D, B plus D, there is no option like that, but you have B minus C is equal to A minus D. Yeah, we have B minus C is equal to A minus D, which will be option number C. Is that the right answer? Yeah, that's the right answer. So basically when they ask you something like this, you just take the parallelogram and say that opposite vectors are getting cancelled out, and so you get one of the answers. Okay, that's about it. Such a simple sum. Okay, let's go to next question. The mass m is lowered with the help of string by distance h. Okay, a mass m is getting lowered with the help of string through a height h at a distance. Okay, acceleration is given by g by 2. Okay, basically there will be an mg which is acting downward, and there will be a tension which is acting upward, and so if it's going to accelerate downward, you know mg minus t is equal to m into a, but in this they've given a to be g by 2. Therefore you can take the tension to the other side, right? Mg minus mg by 2, which will be mg by 2 is equal to tension. So thus I found the tension. The work done is in this will be by the string only, by the tension in the string. So it's tension into displacement. The displacement is it's moving through a distance h. So can we say mgh by 2? Is the answer correct? mgh by 2. That must be correct. I think there is some mistake here, but whatever we did is correct. Let's go to next question. So a lion is at some instant position of a is equal to 2m, 6n, minus 1m, and goat is at, this is lion's position vector, Then this goat whose position vector is at B, which is 1m, at 2m, and an 8m. The lion is free to move, but lion is free to move. Goat is unable to move due to some injury. So this is injured, so restricted. Okay. The lion runs towards the goat and reaches it in time 2 seconds. The average velocity of the lion can be expressed as. So we know the displacement. Let's find the displacement. The displacement is what to say, x2 minus AB vector. The line to run towards the goat is AB vector, which is B minus A, 1 minus 2, which is minus 1i, 2 minus 6 is minus 4j, and 8 plus 1 plus 9k, and that is the displacement. And is able to reach it in 2 seconds. The displacement by time. Okay, this is the displacement by time would give me the velocity. So I can just divide it by 2. So I have minus 1 by 2 into I plus minus 2 into j plus 9 by 2 into k meter per second. You have an option like that, which is your option A, and that's the right answer. So then next, this is the question. A force of vector, the force is given by 2x no 2x into I plus 2 into j vector plus 3 into z square into k cap, this much Newton, is acting on a particle. The work done by this force in displacing the body from 1, 2, 3 to 3, 6, 1, let's find the displacement, is 3 minus 1 is 2i plus 6 minus 2 is 4j plus 1 minus 3 is minus 2k. So that will be the displacement. So இதுதான் displacement. Okay. Work done கேட்குறாங்கன்னா work done is force into displacement தானே. Work done is force in F dot ds. So dot product பண்ணா போதும். So we can dot it, and so you'll get why is it in terms of x and y and all? I think the force of this is acting on a particle. The work done by the force displacing it from this to this is how many joules? Okay. So according to me, I can just dot product them. So I'll get a 4x plus 8 minus 6 z square, and this will be my work done. And how do I find the magnitude of it? Because I have all in terms of x and y. Let me see that. Work done by this force. So when you are not very nice, okay, beautiful sum I couldn't think of. Okay, the work done is force into displacement, right? But you can't when it is in terms of x and z and all. So you just have to integrate every component, x component separately. So integration of 2x into dx plus integration of, and dx is what you don't know. Let's not assume it as a displacement as 2, just assume it as dx only. Okay. So then next is integration of 2 into force into displacement, which is dy, plus integration of 3 into z square into dz. Let it be like that. Okay. So when you integrate, it will be integrated from, don't do the displacement vector it. There is no need to do displacement. This sum you can't do it like that. You know it's going, x is integrated from 1 to 3 x coordinate, y coordinate is going from 2 to 6, z coordinate is from 3 to 1. So you integrate 2x square by 2 plus 2y plus 3 into z cube by 3. So individually they have to integrate it from 1 to 3. This is from 2 to 6. This is from 3 to 1. So when you do this, you will get the proper vector. This is x is 3. 3 3s are 9 into the 18 by 2 is just 9 plus 2 into by minus lower limit. Minus lower limit is just minus 1. So this is solved. Upper limit minus lower limit for this is 12 minus 4 plus 3 into upper limit. 3 and 3 can get cancelled. So its upper limit minus lower limit is 1 minus 3 3 is 27. I'm getting something like that. Let's see. This is 8 plus 12 minus 4 is again 8. So this becomes 16. Okay, and there is a minus 26. So which keeps 10 joules, minus 10 joules is actually more. So whenever you have it as in terms of x, z and all, you can't just do f dot ds. Okay, that's a beautiful sum where you involves integration. So I hope you understood. So that's the answer for this question. Let's go to next question. Next question is a vector A points vertically upward and vector B towards north. Vector A points vertically upward, vector B towards north. The vector product A cross B is okay. So when you getting two vectors, it'll be crossing two vectors, you'll get a vector perpendicular both of this. So vector A points vertically upward. When I say it's upward means J, and that's vector A, and vector B towards north. Can I say, can we keep it as the north and south? Can we keep it as Z, positive Z and negative Z? So then when it is moving, it's towards the north. Can I keep north as minus K? And I, J, K, I'm trying. J cross K is I, and so you get a minus I. Now minus I is, so which means A vector points towards upward. Upward and downward is my y-axis, and negative y-axis is positive J and negative J. The B point towards north. North I'm considering it as minus K, and outer I'm considering it as K. So when I get it as I, I'm getting it as minus I, which is negative x direction. So if I'm going to consider the inward as north and the outward as south, this is as up and this is down. So then this is north and south, then obviously east will be here and west will be here, so it's pointing towards the west. So according to me, B is the right answer. Let's see. Correct answer is A. Let's see how it is possible. Vector A is pointing vertically upward. I think north he is taking it as outer and south he is taking it as inner. That shouldn't matter at all, no? Okay, so then therefore if you assume it like this, so then you know that it's pointing towards the north, which is K. So in that case it will be K, and a J cross K, and a J cross K is just I, positive I, and positive I. If this is north, the outer is going to be north, which means you're going to view it from the other side. This will be your east, and this will be your west. So then therefore it's going to point towards the east, and that's how A is the answer. Okay, it depends on what they're taking. They seem to be taking north as outward. This is north, and that as south. What is near your eyes is north, and what is there as south. Or in other words, you can also do it like this. This is north and this is south, and the vector A is pointing towards the upward, and this is up and this is, no, that's very hard. Okay, just leave it like that. These kind of questions is always hard for us to comprehend the directions. So basically the north is taken as near your eyes and south is taken like that. Okay, so then this is north and that's south, this will be east, and so then it's sorted. Okay, J across K. Let's go to next question. Two identical blocks, 5 kg block are moving with the same speed. Two identical 5 kg block are moving with the same speed, 2 meter per second, towards each other. 2 meter per second towards each other. Along the frictionless horizontal surface, the two blocks collide, stick together, and come to rest. So they both stick together and come to rest. Consider the two blocks as a system. The work done by the external and internal forces are. Since they are colliding and they are coming together, we can consider it as inelastic collision. In inelastic collision, there is a change in the kinetic energy, and the momentum is also not conserved. So you have to find the change in the kinetic energy. That's what they have done. K final minus K initial. Okay, first of all, two identical mass 5 kg are moving towards the same each other, frictionless horizontal surface. Two blocks collide, stick each other, and come to rest. Consider the two blocks as a system. The work done by the external force and internal force. The work done by the external force you're considering it as a system which is isolated. Okay, so then therefore the work done by the external force, they're taking it as 0 minus in addition work done by the internal force. Work done by the internal force is nothing but K final minus K initial. So then K final minus K initial. So K final is they are actually coming to a standstill. Final kinetic energy is 0 minus initial kinetic energy. Initial kinetic energy will be an addition of these two energies because both of them are coming in energy. There's no vector involved, so you can just say 2 times half mv square. So 2 times half mv square, 2 and 2 get cancelled. Thus you get and minus mv square to be the change in the energy. And so minus 5 into 2 square, and therefore minus 20 joule is the work done purely by the internal force. In isolated system, the work done by the external force is 0 nu eduthukurom. Internal forces we can take it as change in kinetic energy. So work done nale conservation of energy, so here change in kinetic energy. Since the initial kinetic energy, actually initial kinetic energy will be not be equal to final kinetic energy. Okay, initial kinetic energy will not be equal to, because this is inelastic collision, so you're trying to find the change in energy and substitute it as the work done. Okay, let's go to the next question. A parallelogram is framed with vector A and B as sides and diagonals. What is it? A parallelogram is framed with vector A vector and B vector as sides, which means if you're going to consider this as B vector, this will also be B vector. Let diagonal D1, let this diagonal be D1 and let the other diagonal be D2 of the parallelogram. Then A square plus B square, small a square plus small b square, which is the magnitude of A the whole square, magnitude of A square plus magnitude of B the whole square. You want to find that, you know that this diagonal D1 itself is A vector plus B vector, correct? A square plus B square. I don't understand what is this capital A and capital B. I didn't understand the question itself. Okay, the multiple choice has got capital A's and capital B, so I think it's only small a and small b, right? It has to be small a and small b. I think they have only done it so badly, their options. So then the diagonal is given by the resultant of parallelogram, which is root of a square plus b square plus 2ab cos theta. That is your D1. And so D1 square is equal to a square plus b square plus 2ab cos theta, and D2 square is also a square plus b square, because either way minus 2ab, because why D2 is with a negative, the D2 is with a negative because the vector, this is like this, whereas this is like this. So but however it is still the resultant. Just trying to think one second. So when you try to calculate D2, let me do it in red color. This is D2, okay? When you try to calculate this D2, you're trying to use the same formula as parallelogram resultant, which is a square, which is magnitude of this and magnitude of this. You have to have plus 2ab cos theta, but cos theta, okay, they are since one of this b vector, the a vector is in this direction, the b vector should be in this direction, so then therefore it becomes minus 2ab cos theta for this one, and you just add these two, but the diagonals are the same, and this gets cancelled. You get a 2a square plus 2b square, which is equal to the two diagonals are just the same, because diagonals of parallelogram, no, they only bisect each other. Where does it say the diagonals are equal? It doesn't say that. So you will get a D1 square plus D2 square. Okay, and It's 2 times a square plus b square. So are they asking about, then the question is wrong. Then the diagonals of the parallelogram, then a square plus b square is equal to d1 square plus d, it must be d1 square plus d2 square. I think the question, there's some confusion here. Okay, total confusion in the question. So let's forget about it. But you understood, if the question is correct, then we can answer whatever they want. So a square plus b square can be half of d1 square plus d2 square, or sum of the diagonals is 2 times a square plus b square. In that case, they are asking sum of the diagonals. Option D is the right answer, where the question should have been not a square plus b square, should have been d1 square plus d2 square. Again, we are not clear, but what we have learnt is this: for one of the diagonals, this is the formula. The one diagonal, this is the formula, is something that seems to be something new that we are learning here. So let's go to next question. In which of the following cases can the work done increase the potential energy? Work done, can it increase the potential energy? So this question is about a non-conservative force. Let's learn what a frictional force is. An example of non-conservative force. Okay, non-conservative force example is frictional force, where there will be heat, wear and tear, and so then loss of heat is happening. So that's what they've given: heat, sound, etc. It does not increase the potential energy. So then in a non-conservative force does not increase the potential energy, but as a conservative force, work done is responsible for increasing or decreasing the the potential energy. So then therefore the work done by the potential energy is due to conservative force only, not due to non-conservative. Just remember that. And so then option number B is the right answer. So let's go to next question. Let the question come out clearly. It's not clear. Yeah. So then let A and B be the vectors which is expressed as A vector is equal to 2i plus j and B vector is equal to I minus j. The unit vector perpendicular to, you have to find a unit vector perpendicular to both A and B. You just have to cross it, right? You already know it. I, j, k, a 2, 1 and 0, a 1 minus 1 and a 0, and a determinant, and it will give you a 0 minus 0 minus j into minus 2 minus 1 plus k into minus 2 minus 1. So then therefore we'll get 3j minus 3k, and the magnitude of it will be root of 9 plus 9 root 18. So 3 by root 18 into 0i plus 0j. Okay, unit vector A and B, unit vector perpendicular both of this, so you have to divide it by its magnitude, which is root of 9 plus 9. So 3 by root 18 into j plus 3 by root 18 into k. So assuming what I've done has no mistakes, 1 minus 1 0, I, j, k, a vector perpendicular to both of this, my answer has to be correct. D is the right answer. D is the right answer, which is just got a k. Why? It's I into minus j into 0 minus 0 again, plus k into, I made a mistake, this and this is also 0, right? So therefore you only have k, which is minus 3k. So then therefore it's minus 3k, but divided by its magnitude is root 9, so which is 3, so minus k vector. Shouldn't it be minus k then? Why are they saying it's plus k? It's minus 2 minus 1. It has to be minus k according to me. Otherwise everything is fine. Okay, so then make sure that you're crossing and writing the right answer. The vector, you have to cross it and divide it by its magnitude to get a unit vector. So let's go to next question. Work done by the conservative force on a system is equal to, we just saw, no, it will attribute to change in potential energy of the system. Means work done by the conservative force is equal to the negative of the change in the potential energy of the system. Okay, so we just saw it. The non-conservative force will not result in change in potential energy. Conservative force will result in change in potential energy. So delta U is the change in the potential energy. dW is the work done by the conservative energy. The work done by the conservative force in the system is always equal to the negative of the change in the potential energy. Change in the potential energy of system. So the option number B is the right answer. But they're saying it's negative of the change in the potential kinetic energy. The work done by the conservative force on the system. The vector area of the triangle, position vectors of whose vertices are A, B, C. See, what they've given is the position vectors are A, B, and C. But to find the area of triangle, you need the side vectors. Okay, so basically, if you need, let's call this as A, B, and C. This is A vector, B vector, and C vector. You get AB vector by doing B minus A. Get AC vector by doing C minus A, and then it's half of this vector cross that vector, which is B minus A cross C minus A. And this will be the area of the triangle's formula. So it's half of, can I just put like this and say B cross C minus B cross A minus A cross C plus A cross A. A cross A will be 0, so I can cancel this off. So I'll have B cross A cross A. So then if I interchange, cross product is anti-commutative. So then I can write half of B cross E so the position vectors are known. So I just have to find the side vector and do half of A cross B magnitude. That's what I did. So B cross C minus B cross A minus A cross C. So that case you can, it is anti-commutative, so I can write B cross C plus A cross B plus C cross A. But I'll still have 1 by 2 only in the denominator. Why are they having 6 as the denominator? The formula is only half of A cross B. What has he done? So I think there's again a mistake in the answer. Should have been by 2, and this is the right answer. Whatever we've done, it's just option number C. With the 2 in the denominator, what they have given is wrong.